Hi all. Actually, last week I shifted the session to Wednesday, so you can. I don't know if you were informed or not, but I asked the NPTEL team to inform you that the uh, session is postponed to Wednesday because of academic reasons of mine. So I think none of you got the information because none of you were there on Wednesday. However, you can find a recording of that lecture on the YouTube channel corresponding to this course. Okay, so this will be my last session, week 12. If you have any doubts further, you can comment under any of the videos, or maybe probably the last video which I'm posting, so that I'll be able to see, or I'll be able to easily find out what you're asking. And if not, you can post in the discussion forum of the NPTEL website corresponding to this channel. So without any further delay, we will go to the final uh, live session contents. Yeah, so last week we were discussing about um, parking, which constituted of on-street parking, off-street parking, and on-street and off-street parking. So here we will be seeing one problem with respect to that, with respect to last week's session, and for this session we will be focusing on suppressed parking demand, a continuation of parking. Then we will be seeing some other road facilities, which will be bus bay, truck buys, and milestones and so on, kilometer stones and so on. So I will try to finish this by this week itself without extending it to the next session also, because we won't be having any. So the first question, parking surface lot for buses and cars is to be designed near an exhibition place. So last week, if you weren't there, or if you hadn't seen my lecture, I discussed about on-street parking and off-street parking. So here this comes under parking space requirement, okay, as per HCM, that is highway capacity manual formula. So let's go ahead with it. So parking surface lot for buses and cars is to be designed near an exhibition place. ADT on road is 12. So this is the, okay, I'm not sharing, right? Yeah, thanks. Just now guessed it. Yeah. So parking surface lot for buses and cars is to be designed near an exhibition place. ADT, which is the average daily traffic on road, is 12,000 vehicles per direction. The traffic composition is, so out of this ADT, 15% comprises of buses and 18% comprises of cars. Design R factor is 0.18, and the usage ratio of this parking space has a usage ratio of 0.28 for both the vehicles. So the duration of stay for bus is 45 minutes and for car is 20 minutes. Using US HCM formula, the parking space required for buses and cars respectively would be what? So given the average daily traffic, or from average daily traffic you can find out how much proportion of it will constitute for the vehicles that require parking. So you're supposed to calculate parking space requirement for a specific vehicle type, right? Now you cannot find it out directly. So in order to get that, you will be given ADT, average daily traffic, and they will tell you what proportion of this average daily traffic is comprised of buses, is comprised of the vehicle which is of interest to you. In this case, it is buses and cars. Okay. So out of this 12,000 vehicles, 15% is buses and 18% is cars, is what they want to say. Now Now, um, there is a formula to find out parking space requirement, which will be out of this ADT, you have to find out what is the proportion of vehicle which is of interest to you, right? So let us say you are finding out a value n. Okay, from this n, you are supposed to find out, so you are supposed to multiply it with the usage ratio, okay, the design R factor, and the duration time. Okay, duration time. Okay, so let us see one by one. So out of this total number of vehicles, you have to find out what amount, uh, how many number of cars and buses will utilize the parking space, right? So that you have to multiply it by, that is why you have to multiply it by the usage ratio, right? Now, out of all this, so you have 18% cars. Let us say you have 200 cars in that area, and out of the 200 cars, only say 100 cars require parking. They are going to park. No, right? Because out of all the vehicles, you know how much percentage of vehicles comprises of cars, but not all cars will require parking. So that is why you have to multiply the number of cars with the usage ratio. How much number of cars will require parking? Okay, so that that when you multiply that, you will find out the number of cars which require parking. Now, all these cars might not park at the same time, right? So there will be a peak hour in which there will be an increased demand. So that you have to find out. That in order to find out, you have to multiply it by design hour factor. For what hour it is going to be the parking is going to be critical, and during that hour, how many number of cars is going to uh, be occupying the parking space. So you will multiply it by design hour factor. Now, you found out um, how many vehicles are required. Sorry, how many vehicles will be using the parking space. Now you also have to find out how much time they will be occupying the parking space, right? Because if it is for the entire day, then that parking space cannot be occupied by any other vehicle. So both the number of vehicles and the time for which they will be parked will play an important role in the parking space requirement. So this entire thing has to be multiplied by duration. So that is what we are going to do now. So let us first find out for buses. Okay. Now ADT is given to be 12,000. This is per direction. Now, irrespective of the direction, your vehicles will be using the parking space, right? Even if it is on this side of the even if it is on one side of the road, the vehicles on the other side, if they want to park, they will obviously go to the parking space which is on the other side, right? So there will not be any designated parking spaces for vehicles traveling on the left and vehicles traveling on the right. So even if it is given, so if the vehicles ADT is given in number of vehicles per direction, you have to multiply it by 2, because the vehicles traveling in both the directions will be occupying the parking space. So now what will be my ADT? So I have to find out ADT for both the directions. So it will be 12,000 into 2. Just a second. actually this has to be multiplied by 2, but in the solution that I have it is divided by 2. I'll just check the answer once. Yeah, so ADT is divided by 2. I don't know why. I will just try to find that out and I will let you know uh, in maybe the discussion forum or maybe in one of the comments under this YouTube video. It is supposed to be into 2, so I will just check once, okay, after this, but we will calculate it for divided by 2 itself, okay, as they have given in the solution manual. Okay, so ADT, it is going to be 6000. Now what did I say? This ADT is for total traffic. Now if you have to get for bus, you have to multiply this ADT into the proportion, which is proportion of ADT which will be comprised of buses. So it is going to be 15%, which is 0.15. Okay, so this will give me number of buses. Now what I have to do is I have to multiply this by usage ratio. Out of these buses, how many buses will be requiring parking? So buses requiring parking will be bus into usage ratio, which is 0.28. Right? Now out of these buses which require parking, how much will be affected? So the parking space will be affected during the peak hour. So how much of buses will be occupying during the peak hour? So this has to be multiplied by design hour factor, which will be bus into 0.28 into 0.18. Okay. Now finally you have to multiply this by the number of hours parking is going to be required. So we've been given 45 minutes. Okay, so this has to be converted to hours. So 45 by 60 is going to be should be so 0.75 should be multiplied by this with this. Okay, so for bus it is going to be, if we do all this for bus, it is going to be 12,000 divided by 2 into 0.15 into 0.28 into 0.18 into 0.75. So if you calculate this, it is going to be 34.0202 or 34. Now we'll do the same thing for car. So it is going to be 12,000 by 2 into how much portion is going to be comprised of car? It is 18%. So 0.18 into the usage ratio is the same, 0.28 into design hour factor is the same, 0.18, but the duration of parking is 20 minutes. Okay, so that is going to be 20 by 60. So this is ADT, this is percentage of car, this is usage ratio, this is design hour factor, and this is duration. Okay, so if you find the answer to this, it will be 90. Okay. Now moving on to the next question. So this is where this week's contents start. Okay. So a multi-level car parking operates from 9 a.m. to 9 p.m. 255 vehicles currently parking in the multi-level car parking with an average duration of 4 hours. 15% of vehicles desiring to be parked are turned away. 80% of turned away parkers have average parking duration of 2 hours and rest have average parking duration of 4 hours. Estimate the additional spaces required to cater the turned down demand. Assume the parking efficiency as 90%. Now to understand this, before we get into the details of this problem, let us first understand the context of this problem. So first, what they are saying is there is a parking space available, but it could not cater to the needs of all the vehicles that desire to be parked, so that want to be parked in that space, okay, which means the parking space is not sufficient. Now they are asking you to find out, based on the details that they've given, they are asking you to find out how much extra space is required in that parking space, so that all the vehicles which come to that place for parking can be parked without being turned away. Okay, so this is called as suppressed parking demand. Okay, so what is a so as I said earlier, suppressed parking demand is you don't have sufficient space and you turn down the vehicles which come to that area for parking. So what are the details given and how are you supposed to find out the additional space required to cater to the needs of the vehicles that have been turned down? Okay. Now, first you have to find out the parking demand of the place, okay, and then only you will be able to find out how much additional parking spaces are required. So in order to find out the parking demand of a place, that is nothing but parking demand is nothing but the number of vehicles, okay, 255 into one second, just a second. Okay. The parking demand, I told you earlier, parking comprises of two components. One is the number of vehicles that require parking and the time duration for which they are going to be parked. Okay, this is going to play a critical role in finding out the parking demand. Why? Because parking demand is obviously the number of vehicles that come to that parking space, and the number of time they spend in that parking space will also play a critical role in parking demand. And as I told you earlier, if a vehicle is going to be parked for 24 hours or the entire parking duration, then one more vehicle cannot be accommodated in that space, right? So parking demand should always be calculated in terms of space hour, okay, both space and hour, or number of spaces per hour. Okay, so what you have to do is you have to find out the number of the parking demand of the vehicles who could park. Okay, before turning down, let us find out the parking demand of the places which could be parked. Okay, so you have 255 vehicles that are currently parked, okay, and they have an average parking duration of 4 hours. Okay. Out of this 255, so 255 vehicles are parked and 15% of the vehicles are turned away, which means 15% more than this 255 are turned away. So if 255% of the vehicles occupy 100% parking space, how many number of vehicles have been uh, okay, I'm not explaining it properly. Just let me explain from the beginning. Okay, 255 vehicles are currently parked. Okay, 15% of the vehicles are turned down, right? Which means 15%. So 15% is which means out of let us say you have n number of vehicles that are that require parking. Okay, out of this only 85% has been accommodated. That is why they say 15% has been turned down. Out of the total number of vehicles that require parking, 15% of the vehicles have been turned down. So the remaining vehicles, the remaining 85% only comprises of 255 vehicles. I hope you understand this. So out of the total number of vehicles approaching the parking area for parking, 15% of the vehicles have been turned down and only 85% have been accommodated. So this 85% only comprises of this 255 vehicles. Okay, so now you have to find out how many number of vehicles have been turned down, because you know just the percentage of vehicles that have been turned down. So you have to find out the number of vehicles that were turned down. So if 85% comprises of 255 vehicles, how much will 100% comprise of? Okay, so this is going to be 8 x is equals to 255 into 100 divided by 85. Okay, so this is going to be 255 divided by 0.85, and this is going to be 300 vehicles. So 300 vehicles had approached the parking space. They had space only for 255 vehicles, and they had to turn down 45 vehicles. Okay, so this we found out. Now out of this 45 vehicles, what this question says is, so 300 minus 255 is 45. Okay, so out of this 45 vehicles, they say that 80% of turned away parkers have average parking duration of 2 hours, and the rest have average parking duration of 4 hours. So this is the number of turned away vehicles. Okay, out of this turned away vehicles, 80% have a parking duration of 2 hours and 20% have a parking duration of 4 hours. Okay, so what did I tell you initially? When you have to find out the parking demand of a place, you have to multiply the number of vehicles into the number of hours required for parking. So how will you find out the parking space required for the 45 vehicles? Okay, though the total number is 45, some of the vehicles require 2-hour parking and some of the vehicles require 4-hour parking. So you have to find out the parking demand accordingly. So parking demand is going to be 45 into 0.8 into 2, because 80% of the 45 vehicles have a parking duration of 2 hours, and the remaining 20% have a parking duration of 4 hours. Okay, and so this will give you 72 plus 36 spaces per hour. So this is the parking demand for turned down vehicles. Okay, in the same way you can find out the parking demand for the vehicles that are currently occupying the space also, provided they tell you how much parking time is required for the vehicles that constitute the 255 vehicles which are parked. Okay, so we have found out the parking demand of the vehicles that have been turned down. Now they are asking you what is the additional space required to cater the turned down demand. So you know the demand for the turned down vehicles, it is 72 plus 36, so 80, 108 parking spaces per hour is the parking demand for the turned down vehicles. how many additional parking spaces is required. So now there is a formula for this. So number of additional parking demand, okay, is equal to efficiency factor into time duration into additional spaces, right? So this is the demand that we just calculated, which is 108 spaces per hour. This is efficiency factor. What is efficiency factor? Let us say the parking space has a capacity to occupy 1000 vehicles. For example, if it has an efficiency of 90%, it means that it can accommodate only 900 vehicles. So its parking efficiency is reduced. So now you cannot say that my parking space can hold 1000 vehicles. It can hold only 900 vehicles. There could be many reasons for this. So this they call it as the efficiency factor. How efficient is my parking space? Can it accommodate for all the parking lots that have been built initially? So it was built for 1000 parking spaces, but 1000 vehicles could not be accommodated, and they found out that only 900 vehicles could be accommodated. So the parking efficiency is 90%. Okay, if only 850 is accommodated, the parking efficiency is 85%. So in this problem they say that the parking efficiency of the place is 90%. So you have to multiply that to this problem. So this is the efficiency factor, and they've asked something called as time duration. So this parking space is available only from 9 a.m. to 9 p.m. So you have time in your equation, right? And you should also appropriately multiply the number of the number of hours the parking space will be uh, available. It is not going to be available for 24 hours a day, not the entire day. So you have to take that into consideration. So you will multiply time duration to this, and this is what you are supposed to find: additional parking spaces. Okay, so now you have to rearrange the equation. N is going to be 0.9 into 12 divided by 108, and this will give me 10. Okay, so the additional parking space is going to be 10. So to summarize, or to just give an overview, this is called as suppressed parking demand, where the vehicles which require parking have been turned down. Okay, so in order, and if in this parking space they require additional parking space to accommodate for the turned down vehicles. Now this turned down vehicles, you have to find out how much additional space is required. In order to find out how much additional space is required, you have to first find out the parking demand for the turned down vehicles. Only then you will be able to find out the additional spaces. So first you will find out the parking demand by multiplying the number of vehicles with the time duration they require for parking. Okay, so that will give me number of spaces per hour, that is the parking demand. And this parking demand, from this parking demand you can find out the additional spaces by using this formula, that is the parking demand is going to be a function of efficiency factor, time duration, and additional spaces. So from this you will find out additional spaces, and this time duration is going to be the time duration for which the parking space is going to be open to the users. Okay, so this is the problem. Now next question: bus bays are usually not required on what? So first let us understand what bus bays is. Now problems on parking is over. We'll move on to bus bays now. So what is a bus bay? A bus bay is a designated lane constructed as part of the highways, okay, meant for picking and dropping of the passengers that use who use the public transport, right? So if you see, this is the number of this is the highway or roadway, and there's an additional lane here which starts only at this location and ends at this location. So if you see here, there's a bus shelter here, okay. We will also see what a bus shelter is. So in our place we will call it as the bus stop, right? So this is the bus stop, and they have a separate lane for the bus to stop here and allow sufficient time for the passengers to board and uh, unboard the bus, right? So why is it required? If you see the okay, imagine yourself traveling behind a bus, and you will be obviously frustrated if a bus is going to pause at regular bus stops, right? So in order to the efficiency of the vehicles traveling behind the bus is going to be reduced, their speed is going to be reduced, right? And this may cause a lot of congestion. So in areas where the traffic volume is high, and there's if the frequency of the public transport if the frequency of buses is high, okay, or there's the frequency of the bus stops, there are a lot of bus stops in that area. So if you follow a bus, if the bus stops at regular intervals, it is going to affect you, right? So in such cases they will provide a designated bus bay, where the bus will enter the bus bay and allow for the passengers to board and unboard the bus. So this way the vehicles traveling in the main lane will not be affected. Now let us see where this bus bay should be provided. So usually this is provided on national highways and state highways. Why is it provided on national highways and state highways? Mostly because the traffic volume is going to be high, and uh, in the presence of a bus, the movement of the traffic is going to be affected. The buses are going to stop for a considerable amount of time, affecting the efficiency of the vehicles, and it will cause congestion to the roadway. This will not be this bus bay. Have you ever seen bus bays provided on other district roads and village roads? Obviously no, because those are obviously low volume roads, so they do not require bus bays. So if you read this question, um, bus bays are not required for other district roads and village roads. In all the other areas the traffic volume is high, and the presence of a bus might disturb the movement of the traffic, okay. Now let us move on to the next question. So you've been asked to find out, you've been given two statements, and you've been asked to find out which statement is correct. Okay. So statement A and B presents the possible reasons behind the provision of a composite bus bay. So as per statement A, it says that it shall be provided, just a second, yeah, it shall be provided if large number of passengers need to transfer between routes. And as per statement B, it says that it shall be provided if the width of the carriageway is more than 2 lanes in each travel direction. Okay. So if you see this problem, as we already saw for bus bay, if there are a large number of people who use the public transport, obviously there's going to be a large number of buses using that particular route, traveling that particular route. So in that case, a bus bay is required. Now, so statement A seems to be correct. Now moving on to statement B, it says that the width of the carriageway is for a bus bay to be provided, the width of the carriageway should be more than 2 lanes in each direction of travel. So this will not affect the provision of bus bay, because as we saw, bus bay is for locations with higher traffic volume, or where the frequency of bus stops or buses is more. So the width of the carriageway is no way going to affect the provision of a bus bay. So the answer to this will be statement A presents the correct reason, but statement B presents incorrect reason. Now moving on to the next question. It is about bus shelter. So first let us see what a bus shelter is. It is nothing but a bus stop provided with a place to sit and a cover over your head. Okay, so this is commonly observed in many places. So this is a bus shelter. Now bus shelter, it will be provided on a raised footpath, okay, for in order for passengers to wait, okay, for their bus. Nothing but a bus stop. Okay, so it will be provided with the seating, basic information about the bus timings, and a protection from the sun. That is a shelter. Okay, that is why it is called a shelter. Now where will it be located? So at what location should this bus shelter be provided? Okay, so it should be provided adjacent to a pedestrian crossing. It should be easily accessible by the residential areas and the surrounding properties. It should be on the footway, okay, and it should be provided near on-street parking. Okay, so these are the locations where a bus shelter can be preferably provided. Now I told you that a bus shelter will have seating, protection from the sun, and in addition to that, I told you that it will have some basic information. So what is this basic information? So it could be a timetable about the bus or the bus schedule, okay, route details, okay. It could be information about the fares, the charge of bus fare, okay, the cost of the bus ticket, or it could be information on alternate routes in the vicinity. It could be what intermediate locations could be served. Okay, so all this information can be provided, will be provided in a bus shelter. If you personally ask me, I've never seen this information. If you have seen, I think you can relate to it. Okay, so all this information are supposed to be provided in a bus shelter. So coming back to the question is about the same. So the information which should be made available at a bus shelter should be what? Should it be alternate stops in the vicinity? Should it be fare for different services and routes? Should it be helpline numbers, or should it be timetable and routes served? So among all the reasons that reasons that I said, you had alternate stops in the vicinity. I told something about alternate stops in the vicinity. I told about fare, okay, bus fare. I told about timetable, that is schedule, and the routes served, but I did not say anything about the helpline numbers. So the answer to this will be A, B, and D. Okay. So now moving on to the next question. Next question is about truck laybys. So what is a truck layby? If you see this figure, you will be able to understand, and if you Um, and as the name clearly says, a truck lay-by is a location for the truck to people of the truck to take rest, or a truck to um, stand by. Okay. And there could be many reasons for this why truck lay-by should be provided. It could be, the basic reason is for the truck person to take rest, right? So most of the time, trucks or lorries, they carry goods from one state to another, right? So it is going to cover a huge distance, and at some point in the roadway you should provide a place for the truck drivers to take rest. Okay, so that is why a truck lay-by is basically provided. There are other reasons for providing the truck lay-by. So in some case, so let us go through them one by one. So I told you that trucks travel from one state to another, crossing boundaries, right? So in some places they may be asked to pay tax at the border. Okay. So in such cases, um, they will they will uh, take a chance to um, rest. They will take a chance to make the necessary arrangements by holding on to the truck lay-by. Okay, a lay-by. Now, say let us go again by the truck crossing boundaries. Okay, so there will be checkposts here and there, and you will be asked for. So you will be um, asked for stopping the vehicles for periodical checking of the uh, goods in the vehicle, right? So in such a case, it may lead to a queue at the checkpost. In such cases, instead of blocking the roadway, they will occupy the truck laybys. Okay, um, and in some cases, sometimes the vehicles will not be allowed to enter the other state for some duration. Okay, not all the time, for some duration they will be restricted. In such cases, they will, so where will they go and um, stop their vehicles? They will occupy this truck lay-by. Okay. A few other reasons would be, if they carry industrial goods. Okay, until if you see, there will be 4 or 5 vehicles traveling together to go to an industrial place to maybe deliver the raw products or collect the products from the finished goods from the industries. Okay, and they will not be let inside all at once. So they will be asked to wait outside the industrial area for industrial premises for some time. So where will they go and rest? They will go and rest in the truck lay-by. Also, if they want to load or unload the commodities, instead of entering the so they are going to trucks are used to transferring goods from one place to another, right? So instead of going inside each and every town to deliver the goods, what they will do is they will ask the small town vendors to collect it from the highways. And in such cases, in order to do this loading and unloading operation without affecting the local traffic, they will occupy the truck lay-by and do this loading and unloading operation. So based on all the points that I said, I think we will be able to solve this question. So the purpose of truck laybys is not to what? So let us see one by one. Act as a local market center for distributors or suppliers, load and unload commodities, provide parking area to trucks waiting to enter industrial premises, provide resting place for the drivers, helpers of the truck. So if you see, the first reason that we saw was providing resting place for the drivers. Next one was they will wait to enter the industrial premises. We also saw about loading and unloading commodities. So the only thing which is not part of the truck lay-by is act as a local market center for distributors or suppliers. What does this mean? So they bring commodities from different places, right? So they will just load or unload by standing in the truck lay-by, but they will not place their vehicles permanently there and start distributing or supplying the commodities that they have brought. Okay, so it will not act as a local market. It will not act as a market where you can come to that place and buy the commodity. It is just used, that place is just used for loading and unloading. If it is going to act as a local market, then it is obviously going to affect the efficiency of the highway by not allowing other trucks to occupy that space. Okay, so the answer to this will be it will not act as a local market center for distributors and suppliers. Moving on to the next question. BRT provides supply in range of dash passengers per hour per direction. Okay. So what is BRT in the first place? We saw about bus bay, we saw about bus shelter, and then we saw about truck lay-by. This BRT is nothing but bus rapid transport. So what is the difference between bus bay and bus rapid transport is a bus bay in a bus bay, the vehicles will be traveling as part of the along with other vehicles on the highway, but only when it needs to stop at a bus stand at a bus stop to load and unload the passengers, it will enter into the bus bay. Okay, and after that it will again get into the regular stream of vehicles. But in a bus rapid transit, what will happen is there will be a designated lane entirely occupied by the buses. No other vehicles will be allowed to enter that bus bay, and this bus will also not enter the regular stream of traffic vehicles. Okay, so this is a bus rapid transit. So what could be the advantages of this? Obviously, if you can see, it is going to reduce the delay of public transport. If you have such, many of us will not opt for public, most of us will feel frustrated about public transport because of the delay that it could cause. Now, if you have something called, so if you are given a choice to go by metro or bus, obviously most of us will choose metro because um, the delay will be very less. You will not have traffic jam when you travel in a metro. You can just get onto the train and in 10 minutes you'll be in your destination. Whereas if you travel in a bus, there are chances of um, getting delayed very much because of traffic. So this bus rapid transit will act very close to a train system where, because no other vehicle is going to be occupying the bus rapid transit except for the bus. Okay, so obviously it is going to uh, reduce the delay. So because of which there will be large number of people who will choose public transport. Okay. This will be a this is what many transportation planners are trying to achieve, to make people use the public transport as much as possible. And what will happen because of this? Because of this, they could obviously reduce the traffic congestion, they could obviously reduce the emissions and the pollutions because of the vehicles. Okay, and as I said earlier, it is going to reduce the delay of the users. Now, when will this be provided? You cannot simply provide a bus rapid transit unless and until there is a huge demand. Okay, I cannot be providing this in a village where the demand is very less, where the traffic flow is also very less. You have to provide only when the demand is very high, for because this is a costly project, right? You have to assign designated place for a bus rapid transit. You have to make arrangements for the bus rapid transit. Say if you see, they have provided guardrails all the way around. They have provided curbs all the way. They have a special station in between. So all this is a costly process. You cannot provide this unless and until you have a huge demand, and this huge demand is what they call as so this huge demand, the value would be 2000 to 45,000 persons per hour per direction. Okay, this is per hour. So this is a very huge demand. Only when you have this huge demand, you will go for a bus rapid transit. Now, one more advantage of this bus rapid transit is it is much low. The cost is much lesser when compared to elevated or underground systems. Obviously, right? For elevated systems, you have to construct flyovers for your trains to move, travel. And underground also, obviously, it is going to be much costlier because you have to do a lot of construction, earth construction, right? Earthworks. So this is obviously lesser in cost, but compared to not providing a bus rapid transit, this is compared to a normal bus bay, this is going to be a costly process. So that is why it requires a huge demand for it to be implemented. And this huge demand, we saw that it is going to be 2000 to 45,000 persons per hour per direction. Okay. Now moving on to the next question. So you are supposed to read A and B and find out the correct answer. So before we see A and B, we will see how this bus rapid transit, what are the ways, what are the different types of bus rapid transit. One is you can provide the bus rapid transit in between. Okay, so this will be my bus rapid transit with just curbs on either side of the bus rapid transit marking the edge of the BRT. Okay, so these are called as bus lanes. Okay, okay, and these so vehicles cannot occupy this unless except for emergency purposes like making a turn or something like that. Okay, only then they can use a bus rapid transit if it is a simply a bus lane. So there are four levels of BRT. One is bus lane, one is busway, one is closed, the other is closed BRT, and the other is hybrid BRT. Sorry, BRT. Okay, so bus lane is what I told you about. It is so this is not provided in the middle. Okay, this is provided alongside a curb. Okay, with an entirely separate lane for a bus. Okay, so vehicles, only buses can travel in this area, but vehicles can occupy this if they have to make a turn or if they have to access an adjacent property. Say they have to move to this side. Okay, only then they can access this bus lane. This is the maybe the lowest level of safety for a bus rapid transit system. Okay, second one is busway. In a busway, so this is provided along a curb. A busway is provided in the on the median. Okay, along the median. So that is what we saw in the previous figure. Okay, so it is provided along the median. Third one is a closed BRT. What is a closed BRT? It is also similar to a busway, but you will have guardrails on either side so that vehicles cannot enter this BRT at all. Okay, so this guardrails will open only at an intersection or at a station. Else, only then the people getting down can access the adjacent roadway. Right? Only in such cases the guardrails will not be there. If not, you will have guardrails, so it will be a closed BRT. The final one is a hybrid BRT. So this is a combination of closed BRT and busway. Okay, so it allows extension of, so it helps the people to access the locations beyond the main network. Okay, so not only the main road, they can access beyond the main road also if they go in for a hybrid BRT. So let us see the statements and find out which one is correct. So as per statement A, it has higher construction and operational costs compared to elevated or underground systems. We saw in the previous problem itself that it is less costly when compared to elevated or underground systems. Moving on to statement B, it can be operated either open as an open, closed or hybrid system. Yes, that is what we saw right now. So the answer to this will be statement A is wrong, whereas statement B is correct. Okay. Now moving on to the next problem. For a bus rapid transit system, the gap between station floor edge and bus floor shall not be more than what? So before we see this, we have to understand what are the components of a bus rapid transit system. It is very similar to say a railway system. Okay, I will not say that it is similar to a regular bus system, but it is very similar to a railway system. So what let us understand the railway system. So you will have a railway track, and then at certain intervals you will be having some stations, right? Each plays as a station, and finally, or at the end of the day, this train will go to a terminal, which will be the final end point, right? So that will be called as a terminal. So this is for a train. Same thing for a bus rapid transit system. So instead of the track, you will be having something called as the bus corridor. Okay, and instead of the stations, the train stations, you will be having stations here also, which is what you can call it as a bus stop, similar to a bus stop. Okay, so you will have corridor stations, and as you saw for a train, all at the end of the day, the trains will go to a the final end point of this track will be a terminal, and here also the bus in the bus rapid transit also you will be having a terminal. Okay, now if you see IRC 124, they would have given you how to design each of these components, how to design a corridor, how to design a station, how to design a terminal. Okay, so let us go through it one by one. If you see a corridor design, okay, this is the corridor, right? This is the corridor, and this corridor, they say that for one way movement it should be 3.5 to 4.4 meters wide, and if it has a passing lane, that is maybe an overtaking lane, it has to be 4 to 5 meters wide. Okay, now it should be provided with a median or a divider, okay, on main carriageway and BRT lane. So to separate this normal traffic from the buses in the BRT, they have to be provided with a median or a divider, okay, like this. The width of the corridor, okay, BRT, it will be different for non-station locations and station locations. Say this has a station here, right? So the width of this will be more compared to a location where there is no station. So if you see here, the central portion is not here, right? The central station. So this and this, the width will differ, okay? And the outer width of the median shall be 4 meters. Now there are many more points that will come under corridor design. So that I will leave it up to you. Now moving on to one more thing we will see about corridor design. Moving on to before moving to station design, So corridor design, we will see this, we will take this example. Okay, figure this is the corridor, this has a station here, so this width is more compared to this width. This corridor does not have a station, right? Now um, what should be the height of the elements? This is the elevation. Now cross sectional elevation, um, what should be the height of the BRT lane at a station? Okay, so this is the BRT lane. It should be at least 0 to 150 mm. So with respect to the traffic, it can be either in level with the traffic line level with the traffic, or it can be up to 150 mm at a higher level than the traffic level. Okay. Um, the station height, this is the station, its height should be same as that of the height of the bus floor. Okay, so if you see this figure, both of them are at the same height. If there is a cycle track provided, it should be at a height of 100 mm, and if there is a bus shelter on the curb side, okay, it should be at a height of 150 mm. Okay, so this and all will come under corridor design. So moving on to station design. So this question is about station design, so I will just discuss what is asked in the question. The gap in mm between the station floor edge and the bus floor shall not be more than what? So this is the station floor and this is the edge. Okay, so this gap from this to the vehicle, the gap shall be only 50 mm, maximum of 50 mm. Okay, only then it will be easy to board. If it is less, obviously it is going to hit the station floor. If it is more, it will be difficult for you to get on. So you should provide a maximum of 50 mm. So this is regarding the question. Okay, regarding station floor. Finally, we will see what terminal is and terminal design. A few points. Okay, so a terminal design, um, as I said, it is just the ends of the corridor. Okay, it is a station area, but it is at the end of the corridor. So it will provide facility for um, interchanging between BRT, bus rapid transit, to other transit services. Okay, and you will be provided with a lot of amenities there, just as we see in a railway station. And so it is just like a holding place for many bus rapid transit vehicles. Okay, so all the vehicles, all the buses will dispatch or start from that point, and finally they end at that point. So this is some information regarding terminal. Discussing terminal design or corridor design and all will make this very laborious, so let us just touch. I just wanted to touch on it before, then and there. Okay, as per the question. Okay, so moving on to the next question. Average spacing between BRT stations shall not be more than what? So you know that bus stops are provided at certain intervals. Okay, they will not be very far away. If you get down at one bus stop, you can obviously walk to the next bus stop. In the same way, BRT also, there is a maximum limit for uh, the distance in between stations. Okay, so for this case, it should not be more than 800 meters. Okay, just like a bus stop, just like distance between the bus stop. Okay, Now moving on to the next question. Um, what statement A says is, it is a location where vehicle is charged for using the high class road facility. Statement B is, user charges are collected over a span of 15 to 25 years to meet the construction and maintenance of the facility. Now, we saw two statements, but they did not mention what they are talking about. So if you see this, they are talking about toll plaza. So toll plaza is not new to us at all. So we'll see what, anyway we'll see what a toll plaza is. Okay, and then we will solve this question. So toll plaza is a location where vehicles use a high class road facility, right? So you will obviously see toll plazas on national highways or expressways like that, right? So this is that is the highest level of road facility in a country, and in order to use that facility you are paying a fee, and that is collected at every toll. Okay, now why are you paying the toll? Because they say that they are collecting the toll because they say that they are providing you good riding surface or good mobility. So in order to make use of this you have to pay me. Now why should I pay uh, for using a road? It is because they would have constructed the roadway, right? But they have to make some revenue from it. So what they will do, they will put toll plazas at regular intervals, okay, and charge you for using that roadway. Now if any maintenance is required, they will make use of that money to do maintenance. Okay, now as I said, it this user fee will be used to, will serve as a revenue to the person who is uh, to the person who is giving you this facility, and that person has invested a lot in the construction of this facility and its operation. Okay, so he should be able to get some benefit out of it, right? So after constructing, he is charging you to make use of it so that he can get something out of it. Okay, now if you see a toll, you will not see the same amount for all the vehicles. Each vehicle will be charged depending upon the type of the vehicle. So in a toll, the fee is going to differ from user to user. Okay, and uh, I told you, once they have constructed it, they will place toll plazas then and there. But for how long will they have those toll plazas? How long will they operate those toll plazas? They will operate it till um, till they are able to get the invested money back. Okay, not only that invested money, they should also be able to get something extra out of it. So they will calculate the number of years accordingly, and they will operate the toll plaza till they are able to get the invested money back. Now, at what locations should this toll plaza be provided? So, a toll plaza, if you see, it requires a lot of space. Why? Because in the toll plaza, you will obviously having a place to weigh the vehicles. Why weighing is required? Because trucks mostly the trucks that travel goods, there is a weight limit on there is a legal weight limit for the vehicles. Okay, so if you go to pavement design, they will give you legal axle load. So there is a legal load that any vehicle should carry. If it carries more than that, then it is going to destroy the pavement. So they will so in order to check that, they will have weighing machines. Okay, like it can be a separate weighing machine or a weigh bridge where you simply go and uh, put your vehicle on a standby, and you will be able to measure it, weigh it. Okay, so if you do that, they will be able to know how much you're carrying, whether you are in the legal load limit or not. So in the all this will be located near a toll, because obviously most of all the vehicles have to stop near the toll, right? And so it will be easy for them to just ask them to uh, come and get their vehicle weighed. Okay, so it will depend on the road land availability. It will be it should be at a place which is free from flooding and submergence, and mostly it will be on a flat land away from urban locations, because in a toll plaza, as you have seen, it it results in a queue, right? So it should not be close to urban locations, then it will lead to congestions. Okay, so when you're selecting a location for a toll plaza, you should have all these in mind. Now, um, how many number of lanes is required? So this will depend on the peak hour traffic. Okay, it will be either for 20 years or 25 years, and um, yeah, so for expressways it is going to be 25 years. And when you are acquiring the land to lay a toll plaza, you should have a few things in mind. One is, you should be providing way bridges, as I said earlier. You should be providing a location for medical assistance or crash assistance. Um, in most of the toll plazas, you will see you will see motels, okay, a resting place for drivers and passengers. And obviously, you would have when you enter each lane, you will be seeing um, a toll booth, right? Like a small room where a person sits and operates the um, plaza, a toll plaza. So that also has to be so you have to provide enough space for constructing that also. So when you when you uh, procure land for, or when you select the land for constructing this toll plaza, you should keep all this in mind. You should pick a land such that the space is sufficient enough to hold all this. Okay. um, okay, now let us see this problem, and when we move on to the next question, we will see the remaining uh, portions of the toll plaza. So what it says is, it is a location where vehicle is charged for using the high class road facility. Yes, this is correct. User charges are collected over a span of 15 to 25 years to meet the construction and maintenance of the facility. This also we saw. So both statements are correct. Moving on to the next question. So there are different types of toll. Okay. So this is something. This question is regarding that. So I will give a brief overview of the different types of toll before we get into this question. So you have something called as semi-automatic toll lane. What is a semi-automatic toll lane? Your vehicle will be identified and your vehicle will be stopped, but you will manually give the money to the toll plaza collector, right? So this is a semi-automatic lane. Okay, there are number of lanes, and each lane they are just giving different lanes, different names to the lane based on how it operates. Okay, so one is, the vehicle is identified automatically, but the money is transferred manually. Okay, so that is a semi-automatic lane. One thing is automatic toll lane. So both the vehicle is identified automatically, the money is also transferred automatically, like fast tags, right? And electronic toll collection. So here there will be no stoppage of vehicles at all. Okay, in the previous thing at least you will be stopped and then your fast tag will be read, but in an electronic toll collection you need not stop the vehicles at all. Okay, so there are three kinds. Now the lane, so the uh, width of the lane will depend upon the type of the lane at the toll plaza. And I will tell you the values. Okay, for a manual collection, it is going to be 3.2 meters. For a smart card toll collection, it is going to be 3.2 meters. For an electronic toll collection, it is going to be 3.5 meters. And for an over dimensional vehicle, if the dimensions of the vehicles is high, it is going to be 4.5 meters. Now based on this, we will match. Semi-automatic lane or a manual lane, both are the same. It is going to be 3.2 meters. Smart card fee collection lane, it is nothing but an automatic toll, that is also 3.2 meters. Electronic toll, we saw it as 3.5 meters, and over dimensional vehicle lane, it is 4.5 meters. So based on this, the answer to this is D. Okay. So moving on to the next question. The design criteria not related to pedestrian subway. So what we saw till now, we saw bus bay, we saw suppressed parking demand, bus bay, bus shelter, truck lay-by, bus rapid transit, toll plaza, and now we have come to pedestrian subway. So before we move on to pedestrian subway, we will see what it comes under. So we, in the previous classes, we saw something called as pedestrian crossing facility, like crosswalk, right? And it will be on the roadway provided with zebra stripes, right? So this is at grade crossing, okay? Something like what we saw for an intersection, at grade, okay? Now if the pedestrian volume is very high, or if the traffic volume is very high, then you cannot provide an at grade crossing. In such cases, so it will result in safety issues for the pedestrian, and it will also affect the efficiency of the vehicles. So what they will do is either they will provide an overpass or an underpass. Okay, so this underpass is subway, and overpass you will call it as overbridge or foot overbridge. Okay. Now, as I told you, it eliminates hazardous interactions of pedestrians with the motorized vehicles, but it requires an extra effort. Okay. Um, if you see pedestrian subway, it is an underground crossing facility, as the name says. Okay. So it can be used both by pedestrians and cyclists. Okay. So the pedestrians, since it is an underground subway, they have to go down to a lower level compared to that of the carriageway. Either by using, it will be provided with stairs or ramps or elevators. Okay, in order to come to the underground facility. Okay, so it is of two types: hump subway and full subway. I am not going to get into the details of it. Now, what are the um, requirements of a subway? Okay, design requirements of a subway. Okay, so it's the width of the subway should be 4.8 meters. Okay, and the vertical clearance below the lower surface of the deck. So let us say this is the subway. Okay, this is the road level. You come down to this subway to use it. This vertical clearance, okay, should be 2.75 meters. Okay, and since it is an underground, you should also be cautious about the illumination level. You should at least provide 50 lux of illumination. It should have CCTV cameras. Okay, this is a main consideration when designing the subway. It should be provided with proper ventilation. It should be provided with tactile tiles. Okay, and it should be provided with ramps. Okay, to access it. So out of all the design criteria we saw, let us see which holds correct for this problem. Okay, so we saw tactile paving is required, we saw security cameras is required, we saw proper ventilation is required, but we did not see guardrails. So the answer to this is guardrails. Okay, it is not required, it is not a design criteria for pedestrian subway. Moving on to the next question. The factors considered while fixing location of pedestrian overbridge. Okay. So before that, we will see something about pedestrian overbridge. So a pedestrian overbridge or foot overbridge, um, it is not of much priority because the walking distance will be more when you go for a foot overbridge. Okay. So uh, why? If you see an underpass, this height will depend on the height of the people. So this is not going to be that much. But if you see an overpass, this is where your vehicles travel. Okay, so this is where your vehicles travel. If you are providing a foot overbridge, you have to travel, you have to climb a lot before you for you to reach the foot overbridge. Okay, so this increases your traveling distance. So what could affect the factors of this the location of this foot overbridges? The pedestrian flow, vehicular flow, the types of users, whether they have any physical uh, challenge or physical challenge, physically impaired. Okay, in either in terms of mobility or vision. It will also depend on the width of the road, right? And it will be provided where um, accidents between pedestrians and vehicles frequently occur. Okay. Other factors could be it should be easily accessible and easily mountable. It should ensure the safety and security of the pedestrians. It should protect the pedestrians from weather, from rain and sun. Um, the way in which the design and the stairs and ramps are designed should be easy to use. So moving on to the question, the factors considered while fixing, yeah, while fixing location of pedestrian overbridges. Is it agricultural land use? Obviously not. Is it history of vehicle pedestrian crashes at location? Yes. Is it land development including pedestrian cross flow? Yes, we saw that pedestrian flow affects this. Is it vehicular movement at relatively high speed? Yes, obviously. If vehicles are moving at relatively high speed, you cannot go for a at grade crossing, right? So now moving on to the next question. Column 1 lists color of, okay. Now we will see something about kilometer stones, popularly called as milestones. So milestones is every miles maybe, kilometers will be in terms of kilometers. Okay, only difference. So there are different colors for this semicircle. So this kilometer stone you will have seen in many places, right? So this they are provided with different colors, and this color will depend on the type of the roadway, right? So they are asking you what color is for which type of road. Okay. So before that we will see the type of kilometer stones. One is an ordinary kilometer stone. It is provided at every kilometer on a national highway, state highway and major district road. There's something called as fifth kilometer stone which will be provided at every 5 kilometers. They are usually bigger in size and they are also used on a national highway, state highway and major district road. And there's something there are separate kilometer stones for other district roads and village roads. Okay, and they have a different size and compared to the other kilometer stones. Okay, now let us see the colors corresponding to kilometer stones on each roadway. So the background color will be white with black letters and numerals. Okay. So color of semicircular portion here will be yellow, canary yellow for national highways, brilliant green for state highways, white for major district roads, okay, and orange for rural roads. Okay, all these you can see here. So yellow for um, national highways, green for state highways, white for major district roads, and orange for rural roads. So the answer to this is D. Degree of access control. So the next question is degree of access control to the highway facility does not depend upon what? So we have had a lot of discussions regarding access control roadways. It means I will restrict the vehicles from accessing the roadway as and when they want. I will control the access of the vehicle to the roadway. So that means I'm providing access control to the roadway or highway facility. Okay. So why is it provided? It will reduce the number of conflicts. This is the major point. It will maintain the functionality of the road. So if the vehicles are traveling in so it will help in maintaining the efficiency of the road. If you allow the vehicles to enter as and when they want, then the vehicles traveling on the roadway have to be cautious all the time, and their speed will reduce, seeing the other vehicles enter the roadway. So if you control the axis, then only that location will have a little efficiency reduction compared to other locations. Okay. Now yeah, so the other reasons would be reducing deceleration requirements on the road. So I told earlier, reducing the speed reduction, reducing or eliminating the turning movements or cues on through lanes, maintaining the level of service of stream. So if the speed is reduced, obviously level of service will be reduced. So in order to maintain the level of service, you have to provide an access controlled highway, and reducing interference from roadside developments, right? So they cannot access the roadway as and when they want. Now um, what will control, what will not control the decide the degree of access control. So will accident frequency control the degree of control the degree of access control? Obviously yes, because it is to reduce accidents. Will highway maintenance costs affect this? Seems something irrelevant. Will land use affect? Yes, because if there is an adjacent development, then you will obviously go for access control, maybe a higher degree of access control, because it will stop the vehicles from this adjacent facility to enter as and when they want. LOS proposed for the highway, obviously yes. In order to maintain a high LOS, you will go for an access control, and for the highest level of LOS, maybe you will go for the highest level of access control. Okay. Other factors which decide the degree of access control will be the traffic pattern, the vehicle operating costs, travel time, okay, and convenience of access to the nearby property. Okay. So moving on to the last question. The lateral clearances on highway facility are provided for what? So what is a lateral clearance? A lateral clearance is, say you have a roadway and you have a bridge pier. Okay, this is the median. You have a bridge pier. Okay, and you have a bridge. You will provide some lateral clearance from the edge of the pier to the edge of the roadway. So this is Lateral clearance. Okay. Now, why should one provide lateral clearance? So, lateral clearance is to ensure the safety of the vehicles. If it is too close, it will obviously hit the piers, right? So, it is main reason it is to ensure the safety of the vehicles. It is to ensure that it is to ensure that there's no unrestricted it is to ensure that it will restrict the movement of the traffic through this facility. Okay, so main reasons for providing this is safety. So if you see the reasons, is it for drain or utilities? Obviously no. Is it for smooth traffic movement? Yes. Is it for safer vehicular movements? Yes. And is it for parking vehicles? Obviously no. So the answer to this will be 2 and 3. So this is it. So this is the last session. If you have any questions, please post it in the discussion forum. Okay. Yeah. So shall we end this session?
Ma'am, what is the question pattern, madam, for the exam?
Sorry. Can you please? Yeah. What were you asking? Pattern of the exam. I'm not sure. Um, um, yeah, you've made a lot of comments. One second, you've made a lot of comments. You've said that ADT maybe it is given for both the directions. I don't think so because in the question it was given per direction. So let me confirm it once later. And the pattern of the exam, I'm not sure of it because you should be asking it in the discussion forum because there will be a regular TA for this course who has a contact with the professor who is taking the course. Uh, so we just give live sessions. He is the one who will be having contact with the professor giving the course. So maybe you should ask in the discussion forum. I hope you know what a discussion forum is because I see no one is asking questions on the discussion forum. Yeah, I think you can post it in the discussion forum, and the respective person will respond. Yeah. Dinesh, you have a question?
Hello, ma'am.
Yeah.
Ma'am, is this session available tomorrow for studying purpose? Today's session.
Today's session, what?
Is it possible that this session will be available tomorrow on the YouTube for studying purpose?
Yeah, I will upload it on the YouTube.
Okay, ma'am. Because the last session was not available. Previous
Last
session.
session is available actually. If you go and check, the last session was on Wednesday. I think they did not inform you. I asked them to shift it to
Okay,
Wednesday.
ma'am.
Yeah, they did. So the session has been uploaded on YouTube. You can go and check.
Okay, okay. Okay, ma'am.
Yeah,
Thank
I'll
you.
upload this on YouTube now.
Okay, thank you.
Okay, okay, yeah. Okay, shall we end this session if this is fine?
Yeah.
Yes, ma'am. Thank you.
Okay, then.
Thank you,
All
madam.
the
Thank you very much.
yeah, all
Thank you,
the
ma'am.
best for your
Thank you.
exams. Bye.
Thank you.